All right, good morning, everyone. My name is Jason, and I'm the technical manager of SuperMap International. Today, I'm glad to be here to discuss with all of you about the SuperMap GIS 10i BitCC technology, BitCC. So, at first, please allow me to take a few minutes to introduce you SuperMap as a company. SuperMap was founded in 1997 under the support of Dr. Zhong Ershun, under the support of China Academy of Science. And the founder of SuperMap is Dr. Zhong Ershun. At first, SuperMap only located in the dormitory of a university, but now SuperMap already have two independent buildings. One is in Beijing and another one is in Chengdu. And the SuperMap got listed in stock exchange markets in 2009. And as we know, SuperMap is the only one public listed GIS company, GIS platform company over the world. And we follow, we also follow the industry standards such as CMMI V5, OGC, and also we got the quality certificates of ISO. And this is the annual revenue of SuperMap from 2015 to 2018. And we can see the revenue grows steady, and the revenue of 2018 is almost 2 or 3 times of 2015. Besides, we invest 18% we invest 18% revenue to the R&D. And SuperMap has more than 4,000 employees all over the world, not only in mainland China, but also we have office in Hong Kong, in Japan, Malaysia, Indonesia, Turkey, and Germany. And this is a part of our international team who attending the annual meeting on 2019. And we have we already built a lot of partner ecosystem. And we already have a lot of win-win solutions with our partners, such as Huawei, such as Microsoft, IBM, and so on. So now let's go to our main topic today, which is the key technologies of SuperMap GIS 10i BitCC. These 5 features make SuperMap different with other GIS platforms. And today I will introduce you them one by one. So we can see the big data GIS, AI GIS, and new 3D GIS is the new technology from IT or from GIS, and the cloud native GIS and cross-platform GIS are the basic of the whole product's architecture. So first, it is the cross-platform GIS. It's very easy to understand. Cross-platform means SuperMap products can not only run on Windows, but also can run on Linux natively. We support Windows, SUSE, CentOS, Red Hat, and other operation systems. So what kind of value of cross-platform? First, as we know, we even cannot control the automatic update of Windows, right? But Linux is more easier to control, and also it has the comprehensive safety policy. So if we can deploy our GIS platform on Linux, that means our GIS application will be more safe and controllable. And the second one is the IT technologies such as big data, such as AI. They are all comes from Linux. I mean, at first, they only can run on Linux. So if we can run GIS products also on Linux natively, that means we can always catch the latest technologies of IT. And the last one is very, very easy, like Linux is free. So then the second feature of SuperMap technology is cloud native GIS. First, there are 4 carriages. We call it as 4 carriages, but it's 4 main products of GIS, of cloud GIS in SuperMap, which is SuperMap App Portal as a GIS portal, SuperMap iServer as the GIS application server, SuperMap iEdge as the GIS Edge server, and also the SuperMap iManager as the cloud manager. So this slide is showing how these four products work together. We can see first we use iServer to publish our spatial data as service, and then the iPortal as a unified access to register to integrate all the GIS resources, such as our spatial data, such as our map, the service, the scene, and other resources. And we use iManager to manage all the cloud GIS system to do the operation and maintenance work on the cloud center. And the iEdge is used on when the user and the cloud center has a long distance and the network is not good. Then in this case, we can deploy one iEdge on the client side to and it can use some proxy and cache technology to enhance the performance of network, the performance of services. And this is one of the case how the cloud products work in an application project. And this is based on a real project, one academy of China, one ministry of China. And at first, they only use SuperMap iServer to access all their database, such as basic geographic database, population, economic geographic database, and others. And then they use iServer to publish all of this spatial data as the services. And on the they based on the service, they make them as one application. And on the website, they use SuperMap iClient to develop their own web application. Also on the desktop side, they developed the PC application. But as the time going, during their daily work, they found that their requirements is higher and higher. It's more and more. Then they based on this iServer to develop more and more application. So there are like 2, 3, 4, 5, 6. But that time, if we only use iServer, it's not enough because iServer only suggests we use one iServer to publish 50 services. But how about if there are 10 iServers? Every iServer has 50 services. In this case, we can use SuperMap iPortal to integrate and manage all the resources published by a server. And then on the province node, because this is a national agency, so on the province node, they use the iEdge to enhance the performance. And then they make all of them as a GIS platform, as an application platform. It can provide the functions like customer service system, decision analysis system, command and dispatch system, and others. And then at this time, SuperMap also released the new technology, new GIS technology on mobile. So they add the mobile app to cooperate with the command and dispatch system. And on the right side, we can see the service aggregation. It means the iManager to do the OM, operation and maintenance, for all the cloud GIS system. And this is the development of SuperMap Cloud GIS technology. At first, from 2010 to 2014, we call it cloud-enabled GIS. That is just a way bring some cloud IT cloud technology to GIS, to publish the spatial data as service. And then we use the cloud-ready GIS. And now we are on the stage of cloud-native GIS. So what is cloud-native GIS? Here, the cloud-native GIS mainly has 3 features. The first one is microservice, and the second one is Docker. The third one is automatic arrangement. I will explain to you of them. The first one is GIS Microservice. As we know, in the traditional cloud GIS system, the minimum unit always is the single GIS server. Like, for example, we use one iServer to publish some services, and the units for the whole system, the minimum unit is the server. But on the microservice, we can split all the services inside of the server into independent, and then combine only the necessary one to different server. So in this way, it can bring us some value, such as from complexity to simplification, and running unit becomes smaller, faster deployment. That means earlier, if one of the service crash or has some problem, it always will affect the performance of the whole server. But if we deploy them as a microservice, then every service are independent. They won't affect others. So this is the GIS microservice. But how we deploy the microservice? We use the container technology, or we use Docker. You can download the Docker image of SuperMap from Docker website, hub.docker.com, use SuperMap, and we use the Docker as a container. Every Docker can contain some of the service and deployed on the server. And besides of Docker, here we can see from the we can take a look at it from the bottom. This is SuperMap GIS 10i, and then we split and refine all the service, and then we use Docker as a container to deploy the service, and then we use the Kubernetes as a GIS arrangement to do the management scheduling. That is dynamic arrangement. Dynamic arrangement and elastic scaling. Besides, SuperMap iManager also provides the functions of one-click deployment of cloud-native GIS environment. It's very easy to use. Don't worry about the cost to learn it. Okay, the third one is new 3D GIS. I think we can say that SuperMap 3D GIS is the best 3D GIS all over the world. And here I will show you the new generation of 3D GIS in 3 parts. The first one is integration of 2D and 3D. So the transition solutions like this one, some of the projects, they use 2D GIS platform with 3D visualization software. They just plus them and show them together. But this one is only a matter of expendency. We call it 2D and 3D linkage. It's not 2D and 3D integration. Why we saw this? Because their data is stored differently. Their functions are independent. Their analysis and the communication is the single line. So for the key points of 2D and 3D integration, we call it, we summarize it as 131. The first one is 2D and 3D integration of software package. That means you only need to use one software to run both of 2D and 3D functions at the same time. And the last one is 2D and 3D integration of data structure. That means all of the 2D data and 3D data are stored in the same database. We use the same spatial data engine to store both of 2D and 3D data. And the 3 is some detailed features of 2D and 3D integration. The first one is 2D and 3D integrated spatial data management. For example, this one is a 3D model data storage management. We store them inside of database with 2D data together. Okay, and the advantage of 3D spatial database, which is customized business attributes, SQL and spatial query, sharing and security. Why we call this as a point? Because we have a lot of experience. Like when we compete the bidding with other software. So a lot of them cannot only can show the 3D scene, but it's very hard for them to do the query, including the SQL query and spatial query. So this is one of it. And the second one is a scene construction of 2D and 3D integration. That means we can store the 3D model as a symbol and then configure the 2D points as 3D symbol automatically, such as the symbolize the 3D scene model symbols, such as this one is a model of tree. And on the software, the red point is only the 2D point, but we can configure it as a 3D. Yeah, here we can say we just choose one for the tree and configure the 2D point as tree automatically, and then we can change to another style. And besides of trees or cars, besides of this, for the 3D pipeline, we can also make the wolf as a symbol, like this. And for only 2D points, we can render them as a wolf in different style. And for the 2D line, we can render them as a 3D pipeline, and also to show the flow. And this is another case. The left side is 2D data, is original 2D vector data, and on the right side it is a 3D scene. So, and the last one is a spatial analysis of 2D and 3D integration. Spatial analysis. Here I listed some of the spatial analysis, such as the 3D measurement, 3D network analysis, show 2D analysis in 3D, and also the GPU analysis. The GPU analysis is the main point of spatial 3D spatial analysis. Okay, so now we already finished the first one, the integration of 2D and 3D of new generation of 3D GIS. And now we go into the second one, which is support multi-source data. There are a lot of new types of data comes when the 3D GIS developed, such as the oblique photogrammetry. The oblique photogrammetry data, I think you are already familiar with it. It just use UAV to fly around, and there will be 5 or 7, even 3 cameras in different angle on the UAV, and it will take picture for one object, such as building, from different angle. And then we can use the professional software to generate the model automatically. So it has some features or some advantages, such as high efficiency, it's very fast, high accuracy, because it is based on camera. So comparing with the man-made model, it has more details, and high realism, and the low cost is very cheap. But there are also some challenges faced by automatic modeling achievements of oblique photography, such as the massive data, because the oblique photography data is always big, and the object extraction is similar as the 2D image data. All the model on oblique photogrammetry are continuous with each other, such as the building and road, they are continuous. We cannot make them independent. And the next one is the effect repair, such as sometimes for the small tree or for the water surface, the oblique photogrammetry effect is not good enough. So how SuperMap GIS face these 3 challenges? First, we can load the OSGB directly. The OSGB is the original or origin data format of oblique photogrammetry. And we can load the OSGB directly. That means we don't need to restore all the model data again and to enhance the performance. We don't need to like copy and or install and store them twice. And the second one is overlay with vector polygon to extract objects. That is, we can overlay the vector data with the 3D with the oblique photogrammetry data, and store all the attributes inside of vector. In this case, we can click the building to call the attributes from vector. And the next one is symbolic modeling. Let me show you. Suggest this is the overlay vector data with oblique photogrammetry, and the 3D model and the overlay with a vector polygon. And we can do the query, like query this building and get the attributes. And there are some other application or usage of object extraction, such as query the attributes, even we can query the units in different floor, even in different floor, in one floor, we can divide them in different units. And thematic map, we can render them in different color and spatial queries. That is based on, such as this one is based on road to do the buffer query. Okay, and the next one is the BIM. BIM is also is another very important data format comes this year. The BIM is building information modeling, and this slide is showing why BIM software needs GIS. Like in the BIM model or BIM software, we always use in the architecture design or construction stage, they always use the BIM software to do the design, to make the plan. But the GIS environment can help to enhance the needs, enhance the value of BIM model on the construction and operation maintenance stage. And why 3D GIS needs BIM? First, it is one of the important data source. And 3D, and if we integrate the BIM model to 3D GIS, it can bring us from outdoor to indoor. There are some of the applications of BIM with GIS intelligent city management application, such as road and bridge construction, city design, project management, and building OM. And there are some key points of integration of 3D GIS and BIM, such as the data import, the guaranteed performance, and retain the ability. Okay, and another value of GIS integrate with BIM is if we have enough BIM model, then the BIM can upgrade to CIM, which is City Information Modeling. So in this case, it needs GIS environment more. Okay, the last one of new generation of 3D GIS, which is support multi-terminals. Not only PC, but also on web or mobile, we can support the 3D model. Such as on website, we use SuperMap iClient 3D for WebGL. That is based on system, and we do the extension development. This is this is one of the video to show functions on WebGL, such as the visualization analysis, the skyline analysis. Also, this is a view sheet analysis. And we can roll down and up to show the ground and underground at the same time. Okay, and the WebGL can support all of the 3D data, such as oblique photogrammetry, like beam, point cloud, 3D field data, and others. And 3D WebGL support all the GIS functions, like the regional clip, the calculation, the space analysis, online configuration scenario, and the visualization, edit, drawing. And on the mobile side, we can also render the 3D scene on mobile. And even on VR, now we support HTC and Oculus VR. Okay, and even on AR, because AR is using the mobile camera. and we can render the building on inside of camera to see the detailed building, detail model of this building. Such as, and also we can show the profile of the building and take a look at the detail or indoor of this building. All right, and as a summary, choose 3D help digital twin city. Okay, the next one is Big Data GIS. For Big Data GIS, we mainly have two directions. The first one is for the typic spatial big data, and for the second direction, it is the classic spatial data. For the distributed reconstruction of classic spatial data. Here we support some of the we support most of the distributed spatial data engines, such as Postgres XL, like or MongoDB, Elasticsearch, HDFS, HBase, and DSF. And here is showing the 10 millionth level of data and do the query. It can respond in 1 second. And besides of the data management, there are also the big data analysis, such as the spatial big data analysis, streaming data, classic GIS distributed reconstruction, and distributed spatial machine learning. Also, this is one of the keys to show the performance of big data analysis. For example, if here we choose, this is a records polygon data which has 22.6 million records, and the total volume is 60.3 GB. And we overlay it with another 3,500 square meters to do the overlay analysis, and for the result, we will get 241,000 records. And if we use the traditional computing, it will take us 42.5 minutes. And we can see the performance, we can see the configuration of this server is pretty good, like 32 CPU, and 64 GB memory. But based on the big data analysis, we can enhance 20 times of performance, and it only needs 4 nodes. Every node has 1 CPU core and 16 GB memory. So we can see the differences between the traditional computing and distributed computing. And besides, there is another feature which is streaming data that is related to the real-time data. The real-time data always comes from the IoT layer, such as our mobile signal, such as our GPS device, or such as even the social media, and they are all real-time data and related to GIS, related to coordinates. And we import it to a SuperMap iServer streaming service, and we can do the filter like attribute filter or spatial filter, and just store them inside. And then we can choose to output it directly to different terminals, or we can store them in our data store, in our database. This is one of the example, the distributed analysis operation, which is geographic fence. And this is to filter them based on the spatial information. And when the flight come into the fence, the color will become to yellow. Okay, and besides, another one is showing the national lines land use no tiling dynamic rendering based on HBase. We can see this data is very big. It's the land use data for all over China, and we use HBase to store it, and we can see the render performance is pretty good. Besides, we don't need to tiling them. Okay, and besides of the big data storage, big data analysis, we have some other functions. We have some other features like visualization, big data visualization. This is showing some of the static visualization of geographic data and some dynamic visualization of geographic data. And and also it can render it can work with real-time real-time data together to show the real-time traffic data. And this is to showing the density analysis using heat map. And another one is the dynamic trajectory of taxis in Chongqing. Chongqing is a very big city in China. Okay, and we use some grid aggregation to show this data again. Okay, as a summary, Big Data GIS is a new engine for smart cities. Okay, now we are going to the last topic, which is AI GIS. SuperMap started to do the R&D of AI GIS from 2019, and we released the first version of AI GIS products on 2019. So this frame is kind of complex. We don't need to take a look at all of them, but we only need to understand. Based on the basic support, there are three parts of functions of AI and GIS, which are GeoAI, AI for GIS, and GIS for AI. First, we can take a look at the GeoAI, which is integrate the AI spatial analysis and processing. For example, this is one of the application which to estimation of housing price impacted by infrastructure. We choose a lot of factors. We choose different factors such as hospital, such as school, such as the environment around that housing, and to do the estimation of price, and got the result like this. It is based on the GeoAI. And another one is to do the object detection. This is a real project in Indonesia. We did it last year, and this is to based on the image data to detect all the palm tree, and even we can detect the thick tree. Okay, and how to do the GeoAI flow? Here, it mainly has three steps. The first one is to prepare the data, and then we can get the symbols. And based on the symbols, we need to build the model, or we need to train the model, and then we will got the models. And the last step is to use the model to detect the object what we want. And this whole flow always need multiple interaction. And SuperMap provides the products of SuperMap iDesktop X. We can use it to do all the flow functions on SuperMap iDesktop X, like the sample generation, the model training, the object detection. And after we got the model, we can also publish our model as a service using SuperMap iServer. And then on the right side, we can see the yellow area. In the model application, we can upload the user data to server, and then server can do the detection and back us with the results of detection. Such as this is one of it. On the right side here, we need to choose the database and the data path, and choose the model. Then we click it to do the classification, and we can get the results. Okay, and the second part of AI GIS, which is AI for GIS. AI for GIS means AI helps GIS software to improve its functions, such as based on AI and AR, we can use our mobile camera to detect the object using inside of the picture or the video or camera, and suggest is to detect the cars, detect the hole, and then we can, based on the location, GPS location of mobile, to upload the information onto server. And this is based on AR and AI to do the measurement. We just use our camera to pin some points at camera, and then we can we can generate it as a polygon. And we can use this to do the serving. Okay, and next is the GIS for AI. GIS for AI means the AI analysis results are placed in GIS for results management, spatial visualization, and analysis. That is, for some AI results, we use GIS to do the visualization of it. Suggest this is a spatial visualization for AI, and it's on a traffic situation monitoring and control system. And the next one is the real-time AI video recognition platform. We can see on the video, first we can recognize all the type of car. And the yellow polygon, this yellow area means the bus tree, the bus road. And if some of the normal car, the vehicle or the motorcycle go into this way, then we can detect the number of it. Okay, so as a summary, AIGIS has 3 parts: the spatial analysis and processing, which is GeoAI, and AI for GIS, GIS for AI. Okay, and the AIGIS empower geointelligence. All right, my presentation is almost finished. And let's take a look at the SuperMap GIS 10i BitCC technology system again with the BitCC, which is Big Data GIS, AI GIS, new 3D GIS, and Cloud Native GIS cross-platform GIS. On the end, here I'm showing the SuperMap GIS 10i product system. On the cloud side, there are like iServer, iPortal, and Manager, and on the edge side, which is SuperMap iEdge. And on the terminal side, we have the PC terminal, the web terminal, and the mobile terminal. All right, thank you everyone for your listening. If you have any questions, please just feel free to ask me, and this is my email. Okay, that's all from me, thank you.